For question 9, you could just use your calculator to answer the first part of the question, but hopefully you can just follow it through without having to resort to that. We're given this function f of x, which is equal to 1 over x minus 1 plus 2 for this domain. We're asked to write down the equation of the horizontal asymptote. So hopefully we should recognise that in essence here we've got a rational function, which is going to be something like that. And then we're told here that it is going to shift 1 unit to the right. So there would be a vertical asymptote here, which goes through x equals 1. But we're asked to find the the horizontal asymptote. So here we can see the horizontal asymptote would be y equals 0. However, the rational the reciprocal function 1 over x has been translated up 2 units, so it would actually be up here somewhere. So we would have a rational function with a vertical asymptote at x equals 1 and a horizontal asymptote at x equals 2, such that we have something like this. For part B, we're asked to find the derivative of f dash x. So let's just take our function f of x and express it using rational exponents. So 1 over x minus 1 can be written as x minus 1 to the negative 1 plus 2. And we can see here that this is actually a composite function, so we're going to need to use the chain rule here. So the chain rule, remember, is going to be u dash v of x multiplied by v dash x. So in the first instance, u dash v of x, so we're going to be differentiating the outside of the function with respect to the inside. So if we differentiate the exponents, it's going to be negative 1 x to the minus 1, and then we're going to subtract 1 from the power because it's minus 2, and then we're going to multiply it by the derivative of the inside. So the derivative of x minus 1 is just 1. So we can say, therefore, that f dash x, the derivative, is just going to be negative x minus 1 to the negative 2. For part C, we're told that g of x equals a e to the negative x plus b for values of x greater than or equal to 1. And we're also told that the graphs of f and g have the same horizontal asymptote, and we're asked to write down the value of b, which means it should be quite straightforward. If we just first of all look at this, so again, here you can use a graphic calculator, but you should recognize that this graph is going to be doing something like this, going through the point here, 0, 1. So therefore, we're told that f and g have the same horizontal asymptote. Up here, we said that y equals 2. Therefore, we're going to have a horizontal asymptote here at y equals 2. So the only way that we can translate this function up to here is if b is 2. Therefore, write down the value of b equals 2. Given that g-1 equals negative e, find the value of a. So the first thing to have a look at here is if we've got g of x equals a e to the negative x plus b. The first thing we want to do is have a look at the derivative, or g dash x. So we should be able to see that that's using the constant multiple rule going to be a multiplied by the derivative of e dash e to the negative x, which is going to be negative e to the negative x. The plus b is going to disappear, and therefore we just end up with negative a e to the negative x. We are told that g-1 equals negative e. So g-1 is going to equal a multiplied by negative e to the negative 1, which we are told is actually equal to negative e. So a multiplied by e to the negative 1 is the same as, so we can write this as negative a over e. So I've just rearranged this here, negative a over e, and we know that is the same as negative e. So therefore we can solve and we end up with a is going to be equal to e squared. So find the value of a is going to equal e squared. For part E, there is a value of x, which the graphs of f and g have the same gradient. Find this gradient. So the way to do this is to graph both of the derivative functions, and then the solution will be where they intersect. So we've said from part B up here that our derivative function for f is this, which is the same as -1 over x minus 1 squared. And therefore, we need to set that equal to the derivative function for g of x, so g dash x, which we've got here. However, we've said that a is equal to e squared. So I can replace the negative a with negative e squared, and that's going to be all over e to the x. So if I graph those two functions separately, and then with the find, analyze, intersection tool on the ETI Inspire, I end up with the value of x equal to 2.